Okay, hey guys, Firefox slideshow. Yep. Today we'll be talking about when to use soft or hard assertions. Assertions are great for enforcing the assumptions or rules of your system, giving you clear and actionable feedback upon violation. An assertion is the enforcement of a condition to hold during program execution. Hard assertions crash the program upon violation. Soft assertions don't crash. And in this debate, it usually boils down to when you're in a long-running context, use soft assertions. In a short-running context, use hard assertions. And I think this is too reductionist, and there's a lot of factors that go into whether you use hard assertions or not, specifically in production. Let's take a look at TigerBeetle. What is TigerBeetle? TigerBeetle is an online transaction processing database. It records business transactions in real time. Simply put, it's a long-running context. It's a database server. This is their website, TigerBeetle.com. So how does TigerBeetle use assertions? Assertions crash the program upon failure. Assertions are enabled in production, retaining their crashing behavior, and there's 11,000 assertions in their code base. Why does TigerBeetle use assertions aggressively? Financial transactions have zero margin for error. They have in-house deterministic simulation testing, which simulates decades of usage for their database, exposing their application to a multitude of scenarios. They have fault injection, so network failures, disk corruptions happen at a much higher rate. In essence, they simulate their software in a much harsher environment compared to production. And this gives them confidence that whatever assertion failures they may have introduced into their application, these will get caught during testing. Assertion failures will be rare during production, and if there are any, then that signals a deficiency in their testing, and that requires urgent attention. Lastly, Zig assertions influence compiler optimization. With any real-time processing domain, you want utmost performance, and in Zig, which is the programming language that they wrote TigerBeetle in, assertions influence compiler optimization, especially in release mode. Though not all languages have this kind of feature. What you're seeing here is the domain-dependent factors dictating the practicality of hard assertions in production. You have correctness guarantees, testing rigor, and performance demands. Correctness guarantees is about the criticality of the entire program's correctness at runtime. So, when you have an assertion failure, can you recover from it? Can you afford to continue running even though some feature of your program is incorrect? With TigerBeetle, no. So hard assertions prevent undefined behavior from executing. Testing rigor is about the depth and coverage of your tests. Hard asserts are safe if your tests catch almost all bugs, production failures that indicate urgent issues. Performance demands is the execution speed requirements. This is only relevant where assertions affect compiler optimizations, really. So when do you use soft or hard assertions? The three factors determine whether hard assertions are practical. Treat them multiplicatively. A weakness in any one factor make hard assertions impractical. The formula that I created is practicality of hard assertions in production is equal to correctness guarantees multiplied by testing rigor and performance demands. An example is without testing, hard assertions would crash your application frequently. So 1 times 0 times 1 would be 0. You should never use hard assertions in production. With TigerBeetle, our golden boy, every single factor is a 1. It's maxed out. So should they use hard assertions? Yes, they should. And they do use hard assertions. Disclaimer, this formula and the values provided are arbitrary. They have zero academic foundation and are intentionally flawed. These simply serve to frame your perspective. Next up is Odin. What is Odin? Odin is a systems programming language with manual memory management. Here we refer to its official compiler implementation. This is their website, odinlang.org. How does Odin use assertions? Assertions crash the program upon failure. Assertions are enabled in production, and they have 2,000 assertions in the code base. Odin's factors are: compilers demand absolute correctness. For them, unit testing and fuzz testing is enough because compilers are not highly concurrent or stateful like a backend server. So something like autonomous testing has less value for Odin. Performance demands. Odin specifically prioritizes compilation speed through high-level architectural choices without chasing micro-optimizations. Instead of micro-optimizing the front end by minimizing its memory consumption, instead they simplify the type system of the language itself and aim to replace the LLVM backend with their own. Compare this to something like Rust with a rich type system but significantly slows down the compilation speed, and something like Zig, where I remember this one pull request, the contributor improved the tokenizer speed by 10%, but they introduced a little bit more memory. I think it's like 5 to 10% more memory. I don't know. It's in the single digit megabytes, and the pull request got rejected because the team, and Andrew Kelly specifically, was prioritizing minimizing the memory consumption of the tokenizer. I personally would have accepted the pull request, but I digress. So with Odin, we have a 1 in correctness guarantees. They need absolute correctness, 0.6 in testing rigor, 0.8 in performance demands. So should they hard assert? Maybe, maybe not, but they do use hard assertions. And you can notice that both TigerBeetle and Odin need absolute correctness, and they both use hard assertions in production. So maybe as long as you need absolute correctness, then you should use hard assertions. Well, let's take a look at Antithesis. Antithesis is an autonomous testing company providing deterministic simulation testing to any software. Applications guide Antithesis' simulator using the assertion SDK. This is their website, antithesis.com. Clarification: in this discussion, we are reviewing the assertion practices of Antithesis customers, not Antithesis' internal practices themselves. How does Antithesis implement their assertion SDK? Soft assertions in all environments with varying behavior. So for development and production, you have no op or logs, while in testing, assertions send metadata to the Antithesis simulator, I think through HTTP requests. Antithesis' customer factors are correctness guarantees. Since Antithesis' aim is to eliminate all your bugs, assume absolute correctness regardless of domain. Testing rigor, they have access to deterministic autonomous testing. Performance demands, Antithesis supports JavaScript and C++ clients, so it varies, but for our purposes, let's consider high performance demands. Something like their customer, which is MongoDB. Yeah, you can see here MongoDB. Okay, just like our golden boy TigerBeetle, Antithesis has a 1 in every factor. So should they use hard assertions? Definitely. But do they use hard assertions? Or do they recommend their customers to use hard assertions? No. Antithesis shows that absolute correctness is not the sole factor in whether you should use hard assertions in production, unlike TigerBeetle and Odin. Insights are, Odin isn't a long-running service, so soft assertions have little value. Also, how would a compiler even recover? Antithesis treats assertions as metadata. Soft assertions let the simulator explore failure severity instead of aborting. This also demonstrates to customers the full extent of bugs prevented by comparing behavior before and after integration. So with soft assertions, this allows the machine learning algorithm to further categorize assertion failures with their severity and what kind of bugs they lead to. Because not all assertion failures are equal. Some assertion failures are just typos or some part of your UI not showing up. Some assertion failures will crash your server. And then as a company, you got to remember that Antithesis is integrating with existing code bases. So for their customers to see the value that they bring, they need a clear before and after comparison of how their code base has improved, what kind of bugs were uncovered without changing the logic of the program completely or at all. Essentially, Antithesis testing recommendations are irrelevant to production environments, and their customers should still be thinking about whether they should be using hard assertions or soft assertions in production. Next is Paytient. Paytient is a SaaS fintech. They're a health payment account provider and finances out-of-pocket healthcare expenses at 0% interest. In other words, Paytient fronts all of your healthcare expenses, and they're allowed to do this because of their sponsor. And this allows you to pay your healthcare expenses periodically, just like credit. This is their website, paytient.com. How does Paytient use assertions? Assertion failures return an HTTP 500 response and announces failures in Slack. Let's look at this link, which is an interview by Isaac.
Domain. So in our case, we're writing web servers, and I don't. If an assertion fails in one isolated corner of my server, I don't want that to result in all of production going down. That would be horrible. I would not sleep. That would be terrible. So the idea, how we have it implemented for our use case instead is that when an assertion fails, that request completely fails, returns a 500, unrecoverable, but everything else in the server keeps operating as expected. Because just because there's something that went wrong in the code for handling one request doesn't mean that I need to shut down everything else. So that also really limits the blast radius, where yes, you're getting this feedback, you're going to know immediately when something goes wrong, but it's just isolated to the code that has the issue in it. So okay, that's more of the.
Okay, and then they also announced failures in Slack. Let's take a look at that part of the interview.
Organized by team, we have a bunch of SQL files, and each of those SQL files returns a count, only a number of rows, and each one of those represents an invariant that must always be true of our data, and then every day we run those against a read replica, and if one of those queries returns any rows or a non-zero count, then we'll send a message out in Slack and say, hey, this invariant was broken, we expect this to be true over this whole database, and then it wasn't in this one way. And now I'm very excited about that. We've already caught a bunch of issues using that. And the key thing about that.
Okay. So I assigned these values for Paytient, 0.7 for correctness guarantees, 0.6 for testing rigor, because they don't use autonomous testing. In the video, it was mentioned that they don't use any kind of generative testing or fuzz testing, but Isaac was planning on doing that eventually. Performance demand 0.7. I'm giving them the benefit of the doubt, and they're using Go, but maybe they use JavaScript on the back end. Who knows? Should they hard assert? Probably not. And do they use hard assertions? No. And again, I'll remind that these values are arbitrary, and you could argue that maybe this value could be higher, it could be lower, whatever. And this is only framing your perspective. So there's zero correlation between the formula's output and an organization's actual testing practices. You can see that TigerBeetle has everything 1, and they use hard assertions, but with Antithesis, they don't use hard assertions. Odin should probably not use hard assertions, or it's inconclusive to say the least, but they use hard assertions. With Paytient, same idea, but they don't use hard assertions. You see, the formula doesn't take into account other environments or the value of soft assertions in each domain. So to truly answer the question, when do you use soft or hard assertions? In development, use hard assertions. While developing locally, littering your console with assertion logs is not helpful. You just need to see the first failure with a stack trace. In testing, if you have autonomous testing, use soft assertions. Use the metadata of your program to help guide your autonomous testing simulator. Anything else like unit tests, fuzz tests, snapshots, use hard assertions. And then for production, I created a diagram here, and I was too lazy to create a digital equivalent for it, so I wrote it on a whiteboard. Yeah, look at that handwriting. I write like a girl. Okay, so if you need absolute correctness, the entire program needs to be correct. You cannot afford a single feature to be wrong. You cannot recover from it. Okay, the neighbor's dogs were way too loud. Let's do that again. Absolute correctness. If your application doesn't require that every single feature is correct during runtime, this probably means that you can recover from some assertion failures. Then use soft assertions. Similar to Paytient, they're a backend server. You return an HTTP response 500 for assertion failures. If you do need absolute correctness, then ask yourself, are you in a long-running context? If not, similar to Odin, you're just a CLI tool, then use hard assertions in production. If you are a long-running context, similar to TigerBeetle, where they are a financial database, ask yourself, do you have autonomous testing? If you do have autonomous testing, use hard assertions, but if you don't, use soft assertions, because you don't have the confidence that your assertions were exercised thoroughly during testing. Okay, let's go back to, most likely you'll be using soft assertions in production, so I wanted to give you an example of how that may look like. Let's go to GoC, backend. Okay, this is a backend server that uses soft assertions. I used this in my previous video, implementation driven testing, but I modified it a little bit, and now it panics and we recover from that panic. Okay, and the idea is we open a TCP server, we send text to it, here we go, we send text to it, the client, and then the server saves this text in a database, incrementing every time it's seen. And whenever there's an assertion failure, the server will panic. Now to continue running, we recover from this panic here. And we periodically check in a separate Go routine how many assertion failures happened. So here, if there's any assertion failure that happened within X amount of time, then we send an email to someone and they need to fix that issue. And here, we check it every 30 seconds. And to send an email, we simply use SMTP here with Google App Passwords. I have my credentials in a separate file. I'm not going to show you that. Okay, so it's hard to visualize this. Let's run the program instead. Go run. Yeah, now we're listening. And netcat 49447, 49447. And now we can start typing anything. Hello, what, and let's do you gave me up. Okay, now we have an assertion failure. Let's do that again. You gave me up. You gave me up. Okay. Okay, there you go. It announced the assertion failures via email. Let's just check. Let's just do another assertion failure. And after this gets announced via email, actually let's shut down the server immediately. So what the server will do is, upon shutdown, it will flush out every assertion failure and it will do one final check to announce it via email. So we should expect two emails. One that says 3 assertion failures happened within the last 30 seconds, and then another that says 1 assertion failure happened within the last 30 seconds. Okay? I'm going to go to my Gmail account. And there you see. Detected 3 assertion failures in the last 30 seconds. Detected 1 assertion failure in the last 30 seconds. 0 minutes ago. Yeah. So the code is available on GitHub. I'll put the link down in the description. Hopefully you learned something from this video and you can apply soft and hard assertions in your own projects and hopefully in your workplace. The end. Stay hydrated.